Welcome everybody to this seminar on SolidWorks sheet metal. It's actually the second seminar I've done, or I'm doing. The first seminar I did years ago, and it is posted. If you go to go/x mechanical, that's the website for my group, and we've got training and tutorials. And there's a great hour and a half, 2-hour video on sheet metal. I'm going to do a lot of the similar type of stuff in here. The last one that I did really was concentrating on the manufacturing process. And in this one, I'm going to show you pretty much all the features and some of the new stuff that they've added since that last presentation. Also, if you are starting with sheet metal new, it's a really good idea to go to the help pull down. SolidWorks comes with some great tutorials. If I show all of them, they're alphabetical. So I just look in here. They got a few different sheet metal tools. One on making just regular sheet metal parts and one on doing sheet metal forming tools. I'm going to cover both of those here, but it's always good to get your hands on the program itself so you can understand and build that muscle memory on how you actually create sheet metal parts. Without further ado, I'm going to go ahead and get started on a new part. So I'm also going to open up a part, and I'm going to start a sketch like you do with any SolidWorks part to get it started. I'm going to draw some lines here. I want some of them at an angle. And remember, I've got that trick that if I start drawing a line, come back to the original endpoint, I can turn it into a tangent arc. And there we go. That's the shape that I'm after. I just have to start giving it some dimensions here. So the first dimension will resize my item here, and I'm going to continue putting in some dimensions, start getting some angles and such here. All right. So as I continue to put in the dimensions, you'll see that it starts to get fully defined. And I want this point. I'll hold my control key, select this point, put those right over each other. I still have one piece that's underdefined. Here's a trick on dimensioning. When you dimension an arc, if you then dimension the end points of that arc, you get an arc length. And that gives me the shape of this sheet metal clip that I'm designing. I'll go into my sheet metal tools. If you don't see those, you can always right click on your command manager and you'll see all the different toolbars that you can bring up. I've brought up the sheet metal tab already. And I'm going to use this tool that's called a base flange. Also, you can use it to put on in tabs. I'll do that a little later. But I'm going to say that I'd like to create a base flange. You'll see that it's similar to an extrusion as far as my direction 1. I can put a depth here. I can change the end condition if I have other items that I want to go up to. But currently, I just want a blind condition. And I also have the parameters for the sheet metal itself in here. So if we take a look at this, trying to look straight onto this thing, you'll see that if I have a sharp corner, SolidWorks will break that sharp corner, it'll round it off for me. The size that it's going to round it off has to do with this number right here, which is the inside bend radius of any curve. So any sharp corner is going to get that inside bend radius. You'll see if I start pumping it up, that thing will get further and further away from the sharp corner. When you already have a radius like this, I've got a radius of 100, it'll just use that radius if you've called out a particular radius in your sketch. But again, if it's a sharp corner, it'll break that sharp corner with that inside bend radius. Also, here is my material thickness. If I pump this up, I get thicker pieces of metal. If we had Excel on our machines, you could click on here. SolidWorks has an Excel-driven gauge table where you can pick, from a list of steel and aluminum gauges. Unfortunately, typically we don't have Excel on here, so you just have to go to Google and find your gauge tables or memorize them, like I've got here. Put in the 12 gauge size of metal. I can also determine whether it's to the inside or the outside of that sketch using this reverse direction toggle. So these first two are my extrude depth. Coming down here, I've got the sheet metal thickness and my inside bend radius. Other things that determine how this is going to flatten out have to do with bend allowance. So when you create a piece of sheet metal, you start off with a smaller piece of metal than you need. The actual manufacturing process of bending this thing stretches the metal. So when SolidWorks calculates the flat for us, the flat's going to be smaller than the shape that I've drawn here. And that's determined by this K factor. K factor is just a constant. It's like a ballpark. 0.5 is great for steel, about 0.45 for aluminum. But I can also use just a hard bend allowance, which will add that much stretch for each bend. You can do bend deduction, or you can also do a bend calculation or a table where it'll look up different types of stretch that it's going to do for different tools that you use or for different angles that you bend it through. This is usually for the people who are bending it. A lot of times here at X, where I work, if we're going to produce something, a bunch of them, we're going to have an outside vendor doing it, and they don't really care about our flat calculations. You'll see that when I do the flat, it's more of just a reality check to make sure that my steel isn't running into itself when it flattens out. The last thing here is auto relief, and you'll see that when I start adding tabs a little later, that auto relief is going to come into play. Rectangular is when you would do it with a saw. You'd cut your reliefs, a square relief out. Tear just removes a surface of material. The only time that you'd use tear is if you don't want to see an auto relief, or if this is really soft or thin metal like a brass or a really small gauge. Ob-round is sort of like the rectangular auto relief, but it rounds off the top. And this is great for when you're going to be laser cutting or water jetting the shape, which typically you are for a piece of sheet metal. So I'll set it to that ob-round type. Say okay. And now I've got my sheet metal part. The difference in this between a extrusion and a sheet metal part is I have a whole lot more features. So for one feature that I created, I ended up with 3 features in my feature manager tree. This first feature just holds the information about the metal. When you're working with a sheet metal part, it's a uniform thickness of metal, and that's where this is stored. It stores my thickness right here. It stores my inside bend radius, K factor, and auto relief. If I need to change any of that information, that's where that's stored in that sheet metal feature. If I need to change the depth of my extrusion, I can go in here and you'll see that this all of a sudden has gotten a lot shorter than it was when I originally did it in the property manager creating the feature, where all the information that has to do with the sheet metal is grayed out. If I want to overwrite it, I can, but by default, it's going to be set to use the same thickness of sheet metal that we've got throughout the entire part. I can change my extrusion depth if I want to, but I'm okay with that, so I'll say okay. And this last feature, which is suppressed by default, is a folder of flat patterns. A little later, I'm going to do a multi-body part, and you'll see that you can actually have a flat pattern for each piece of sheet metal that's in that multi-body part. But if I go to my toolbar up here, I've got this flatten button. When I click on it, what it does is it unsuppresses that flat pattern for me. And this is where it's calculated that stretch for me. So it's calculated, this is a smaller piece, and it's going to get stretched 3 different times to get bent. So you see inside of the base flange feature itself, I have access to each bend. So one bend is a really big one. Looks like it's going to be rolled rather than pressed. And these two are going to be done on a press brake. This one's going to have that 100 millimeter radius because that's what I drew it on at the sketch. But these other two are using that inside bend radius of 1 that I specified when I first created it. You can break these from the pack. If I want to go in here and edit the feature on one of these bends, I can change the inside bend radius on a particular bend if I want to. So in this case, I'm going to make this one a little looser bend using a 3 millimeter tool instead of that 1 millimeter that I had down here. So you do have access to the original sketch, all of the bends. When you flatten the part out, you not only see the flat, but you can also go in and edit the flat pattern feature. When I edit the flat pattern itself, it allows me to do different things. Right now, it's using this flat face. For some reason, it chose that as the fixed face, meaning that when I unfold things, that face stays still. Not really great for this part that I'm creating here, because when I flatten it, it's not parallel to any plane. Here's my top plane right here. Let me go back into the feature of that flat pattern, and I'm going to change it to say, instead of having that be the fixed face, I want this to be the fixed face. And now you'll see that when I am in the isometric view, I flatten and fold, I'm getting the expected results that I want, where it's keeping that face that I selected still while the rest of it unfolds. If we take a look deeper into this flat pattern feature, if I edit it, there's all sorts of other things that I can do. This merge faces, simplify bend, show slit, corner treatment. You may not know what any of that is. If you don't, let's click on the help, because they got some great illustrations here as far as when they merge faces. Do you have a face in between the bend and the flat parts or not? When you've got an area that the bend is starting to deform the part, you can simplify that, give you less geometry in here. Sometimes when you do corners, you may want to have a slit or not. So different things that we can do inside of the flat pattern itself. And I'll get into some of that a little later in this example. So that's the main feature inside SolidWorks, this base flange. And you can see that once I've created that, I get all these other types of features available because I finally have a sheet metal part that I can start adding sheet metal features to. Not all of them have to be, sheet metal features. I can just do a regular feature on a piece of sheet metal. I'm going to drill a hole into this thing. So I put in my dimensions as usual. Tell it where I want this thing located. Five. Okay, now that's fully defined. So I'm going to cut this hole, and you'll see that here is a difference when you're inside of a sheet metal part. You have this length to thickness checkbox, and that basically just makes the cut go whatever the thickness is of the part. So if I go into my sheet metal part and I change it from 12 gauge to 18 gauge, that hole is only going to go as deep as the material that it's cutting into. I'm not after that though. I want this hole to go all the way through. When I do a through cut, I get another choice here, and that's a normal cut. I'm going to leave it on right now. It's on by default. And let's take a look at what that does for us. I'll make this part transparent, make it a little easier to see what's going on. When I highlight this cut, you can see that it's cutting here perpendicular to the metal, and then above, it's also cutting perpendicular to the metal. So what it does is it takes that cut, and instead of just cutting it straight like a cylinder, it creates that view. If I'm looking at it from the top, it looks like a circle, but it's coming straight from that metal. And what that does for me is that when I flatten this, this isn't at an angle. It's going straight into my flat. It is, however, changing the size of that. That's not a true circle. If I were to go into my sketch dimensions and just put in reference dimensions, I can put in a reference dimension to this part of the cut because it's a true circle, but this one is not. It's ellipse on either side, and then it's got a little bit of a gap in between. I guess it's two ellipses. But it deforms that shape as it cuts through the metal. Let's fold this back up. And I'll change the transparency again. And this time I'm going to edit the feature just to show you that if it's not a normal cut, how that looks, where it's truly a circle. It's going through like a cylinder. It's just being extruded like a cylinder. When it hits that other face, it does not change direction like the other one did, where it was going perpendicular to the material face. But that is on by default because typically that is what you're after. You don't want to have to cut things into your flat pattern at an angle. And so that normal cut makes sure that all the cuts that you do always go perpendicular into the face of that sheet metal. As I go through the features here, I'm going to do an edge flange, which is one that I do a lot. When you pick an edge flange and you pick an edge, it creates a flange off of that edge, as you might expect. It is going to do the entire edge if you just say okay at this point. But if you don't want the entire edge, you can hit this Edit Flange Profile, and it takes you into the Sketcher tool. And it keeps you up to date as to whether this is a valid sketch or not. By default, it will still be the same size as that edge that I picked, but now I can click and grab and drag these things to a different location. And I can do tricks like I can select the midpoint on that line, hold my mouse button down, pick this edge, and put that right in the middle there. You'll see that it starts showing you a preview right away if the sketch is valid. If the sketch is not valid, the preview will go away. Like if I go into the sketch tools here and I cap this off with a tangent arc, now all of a sudden the preview disappears until I do something to fix that issue. Okay, so it's giving me my preview again. I just really need to start putting some dimensions on this thing. How far I want it to come down. How big this hole is. You see that you can do nested contours. That is fine. And when I finish, it fills in that whole shape that I did with a tab. Of course, this will flatten just like the rest of it. But let's take a look at that edge flange again. I'm going to edit this because there's a lot of settings there. There's the setting for just the edge that you've got and the profile. But you can also play around with what angle this happens at. You do want to draw it to target. So sometimes when they bend things, they have to overbend it because it'll snap back. But you just draw it to target. Again, the guys that are bending it really don't care about our CAD so much. There is an important one right here where I can pick where I want the flange to happen. So you see that it was set to this where it's going one bend radius out from the part. If I go to the inside, that means that this flat face is flush with this side of the part. And you see that once I start doing that, those reliefs start getting cut. That's that ob-round relief that I put in. It starts off with the default, And typically it's half the size of the material is the size of this gap. But I can also put in whatever size I want here, X and Y, if I want to. If you go to the inside, that means that this outside face on my flange is flush with the side face of the part at this point, and my reliefs go a little deeper. So with this thick piece of metal, if you don't put that relief in there and you try to bend this tab, it's just going to mangle this corner. So when you are creating the sheet metal parts, you do need to have some relief in there to allow you to break that corner without just ruining this edge of the part here. Okay. So I showed you a cut that when it hits an angle face, what it'll do with that normal cut. Also, sometimes you may want to cut across a bend. If that is the case, what you want to do is you want to use this unfold tool. What the unfold tool allows me to do is I can hold a face still and pick a couple of bends that I want to unfold. And it just unfolds those bends that I specified in the tool. And now I can do a cut that crosses these bends. And when the part gets refolded, that of course, the size of this will get warped around that corner using the K factor like it should. You can use fillet tools, just like you can on a regular part, if you want to round off some of these edges. There we go. So I'm finished with the shape of the hole that I want in the flat. Now I want to see what it looks like folded up again. So whenever you unfold, you have to do the opposite and fold it back up. It's pretty easy. It remembers the face that you selected. And also, if you hit the collect bends, it goes and gets all the bends that you flattened from your earlier feature. So there we go. You see that it's stretched that hole across these two bends using that K factor, that bend allowance that I set up in my original sheet metal feature. I always try and take advantage of symmetry whenever I'm building anything, and sheet metal is no different. When it comes to doing mirrors, it's really difficult to mirror features in sheet metal. There's only a few of the sheet metal features that will mirror, like edge flanges will mirror, so will forming tools, but other things, base flanges and things like that have trouble mirroring, especially things have trouble mirroring if you've got like up to next or up to vertex or something like that that doesn't exist on the other side. So usually when I am mirroring stuff in sheet metal, I'll just build half of the part itself. And instead of trying to mirror all the features, I'll just mirror the body. It still retains its flat pattern when you do that. So if I go to sheet metal and I flatten it, it knows to flatten, both sides of these flanges. And now I've got a symmetrical part. I'm going to save this because I want to make a drawing out of it. Just call it clip. Let's make a drawing. So I'll just put it on a blank piece of paper here and give you the idea of what you can do. When you have a sheet metal part, you have in your view palette, and also when you do an insert model view, it'll be listed in the different model views, this one called flat pattern. So when SolidWorks sees that a part that's being put into a drawing has a flat pattern, it'll give you that as an option for one of the drawing views. I'll just drag and drop that in there. You'll see it puts in bend notes as to which direction they're supposed to go and bend lines by default. I'll do a projected view, which I'd rather do my projected view above it. Doesn't really matter because all that this view does for us is tell people what the gauge is. All right, these sometimes are troubling to people. These come in automatically. If you do not want them to come in at all, it is an option. If I go into my options here, and under the document properties, there's a whole section on sheet metal as far as whether I want to display bend notes or not. It's not retroactive. If I turn this off, they're not going to disappear. They're still there. It's just on creation. Is it going to have them on creation is the question. Some people get confused by that because they'll turn it off and the things are still there. I'm going to get rid of them. I just want to show you. So you also have, different colors you can do. If you want to have your bend up be red or green, you can edit that color. Also, the font that you have on the note, all that sort of stuff is set up inside of the document properties under sheet metal. You do want to be aware that these are notes. So if I click on them, I move them around, I can drag them off. That's usually the problem, is that there's blocking your geometry. If you do want to do that, you can add a leader to the note if you want to specify where exactly that is. If you don't want to see the notes at all, the delete key doesn't do anything for me. I'm picking delete and it's saying none of this could be deleted. Unfortunately, just like it said, it can't be deleted. But what you can do is you can group select them and you can choose to hide all of those. So if you put them in already, the only thing you can really do is just hide them. I'm just looking at this and I'm realizing people are going to be handling this. They might cut themselves. Let me go back into my part because I forgot one feature that I wanted to show you. Under this corners tool, there's a break corners. When you have this tool on, you pick a face, it'll find every external corner that's on that face and break it, either chamfering it off or filleting it away, depending on which break type you're after. It has trouble, it won't do any internal edges, and it also has trouble on a really complex piece like this. I should be able to pick these edges, but because they're edges that are on a bend, it's not figuring it out with this break corner. The break corner is really, you pick a face, it finds all the sharp external edges and breaks them off for you. As long as your number is small enough to fit in those breaks. So now I can have somebody, grab a hold of this here without cutting their thumb, but this is still problematic. If the break corners won't work, you can just use the good old-fashioned fillet tool. It has a much better track record with, no matter how complex the thing is, it's able to figure out what it would need to round that off for you. And there we go. So I'll save that change, hold my control key and hit tab, switches me over to my drawing. And now I see those broken corners there. I feel much better about having the general public handle this. When you are putting in dimensions, a lot of times, if you are showing a flat, you have this where you can call out the gauge, maybe. I just need to go back into my options. I'm in the ISO standard here, and it makes my head hurt. There we go. Okay, that's usually what I want a dimension to look like. Another thing is people like to do ordinate dimensions with their sheet metal. So if I say ordinate dimension, I don't have to really pick a direction. The direction is determined by my first selection. The first selection that I do will be my 0. And then I can hit numbers here, like if I want to show where all my bend lines are, where all my holes are, I can do that. Then I realized, yeah, that's not the right 0. If you want to change your ordinate dimension, you can simply click and drag the 0 to another location. What have I done to my SolidWorks? Yeah. Okay. Need to put in more dimensions. I can add to ordinate like that. But I don't know why it's being so contrary for me. It should come up with a warning for me that tells me I'm moving my 0 and it's got to recalculate them all. I'm not sure what's going on here. So let me just redo that. Sorry about that. 0. You see that when you do start to run into one another, it will space them as you put in more of these dimensions. Also, it did a good job at showing me where these centers for my holes are, but it did not do it for this punch. If I go into my centerline tool, pick two edges, it'll put a center line between the median of those two edges. So it is truly the median. If those were at an angle, we figure out where the middle was in between the two of them. But since they're straight up and down, you can see that it's pretty smart about what it's going to give me. And there we go. Now I can see where the center of that punch is going to be. If I want to add to the ordinate, I can just right click, say let's add to ordinate, put in that for a dimension. You can also use a center line for an ordinate if you really wanted to. This is a symmetric part, so you can do that and you'll see that it figures out what's on which side. Typically, you also want to have a dimension that is the extents of the part to let them know how big it is. Again, this is if we're creating the flat. A lot of times when you're sending off to a vendor, all they want is your folded part as far as the drawing and the dimensions that you're after. But if we're doing it in-house, or if you really have some sort of reason why you want to show them what you want the flat to look like, we can do this type of drawing. And they can actually use that as a cutter. If I go back into my view palette, there's also bent up versions of this part. I can still put in views here, front, left, right, ISO. As I said before, this is typically the people that are making the sheet metal are much more concerned with the dimensions that you put here, because this is what the target is. This is what they're trying to make it look like. Their tools might have a different K factor than what you did for your flat, or they might have some sort of different process or something like that. So they typically don't use their flat. They're trying to hit these numbers that you have on your folded part. There we go. That's how you make a sheet metal part and create a drawing for that. If anybody has any questions for me, let me know. Otherwise, I will move on here. All right, the next part I'm going to do is a rolled part. That part that I just showed you was probably going to be made in a press brake. They'd laser cut the thing, and then most of it would be done with the press brake. That rounded side might have to be done with a roller. But I'm going to do a part that definitely is going to need to be rolled. When you're doing the math for a press brake, as far as the flat pattern, the mathematics is much more straightforward when you're doing with a press brake. You're always going to get the same amount of stretch every time you bend this thing if you're using the same machine. when you're doing a roller, it depends on how, you know, how much the guy bears down on it, really, for the amount of stretch that you're going to have on that. So, all right, what I'm doing here is I'm going to create a shape here. Do some tangent arcs. I want to have this cylinder that's rolled, and I'm going to have it overlap so that I can have a really strong seam here. Just a trick, if you pick a point where a line and an arc come together, make those tangent rather than having to pick both items like you used to in earlier versions of SolidWorks. All right. Almost done with my geometry here. Now I just want to flesh out what the size of this is. I put in what I want for my radius. Radius of 3. And I'll do a box select so I get both of these lines. I'll make those equal to each other. Also, if you put in a dimension between two concentric circles, it'll give you an offset dimension. And this dimension is going to have to be thicker than the sheet metal gauge that I'm going to be using. But that's really the only thing I have to worry about. Drag this over and snap it. Now we got a fully defined shape for this sheet metal cylinder. I'll use the base flange, the same tool that I used before. Just stretch it out however far I want this thing. Okay, so I've got 75 millimeter, and I've just got it a little thicker, you know, than my material gauge. But this will flatten out just like that last part that I did. The rolled bend is just one bend line here with a really giant radius, a radius of 33 that I put in there when I created my sketch. If I want to do anything on the face of this cylinder, it depends on how I want to do it. So I can, of course, just pick a face and do a hole wizard hole. If I want to drill a hole into this thing, it's going to go straight towards the center. And cut a hole that's a perfect hole when you have the thing rolled up. If I want it to be a perfect hole when it's flattened, I'm going to use that unroll tool again. So I'll choose to unfold. When you're doing the face on a rolled part like this, you don't do a fixed face like I did with that press brake part where I just had a flat face that I could say, hey, hold this still. Especially if you don't have this jog here. What you need to do is you need to pick an edge and say that's going to be what you're going to unfold around. I can use either edge here. And then I want to unfold just this major flat piece. And on here, I'm going to just create a hole. Dimension a certain distance from the edges. And there we go. It's fully defined. Again, I'll do an extruded cut and just leave it at length to thickness. Put a hole in that sheet metal. There's a tool that I'm going to use here that you may or may not have used before, something called a fill pattern. If you want an entire face to have a pattern of holes, like I want to have this hole all over that face. When I pick the face, starts putting in the holes, I can monkey around with the spacing on the holes, and you'll see that as the spacing gets tighter, it's able to put in more holes for me. You can also play around with the angle that they're coming across from each other. Using these numbers right here. Or the type of pattern that it's going to do. These two patterns are more for circular types of faces. These are for square faces, whether I want to have it staggered or just rows and columns. It's up to me. But that'll put a whole lot of holes in there for me. Just like I did before, I'll go into my sheet metal, choose fold, select the bend that I did. And now it's taken that they're perfect holes when it's flat. So it's sort of the opposite of what I did with that normal 2 cut. They're perfect holes when I do my flat pattern. And then those holes get deformed or stretched. You know, it's a wider here than it is here because of that K factor is actually stretching those holes around that sheet metal bend. All right, so that's using that base flange, which does most of the heavy lifting for me in sheet metal. I'm certainly going to use the tool again before this thing is over. Let's take a look at some other applications that you might use the sheet metal tools for. So I've opened up a part here. I can actually get this online. The good people at Google have an open source for their cardboard VR headset type of thing. So I downloaded this. Luckily, Google uses SolidWorks, so this is a native SolidWorks part. I can make changes to it, or if I want to customize it. I just want to use one of these. Here's this part. If you have what they call a master model, if you have a bunch of parts drawn and you want to break them out into their own individual parts, you can do that. If you right click on a body and say insert to new part, what that new part is going to look like is it's going to look just like the body that you selected. But now I can save this with its own part number and process that. This has an external reference to the master model. So the master model, you're going to have to keep it updated if you make changes. Typically, you want to make them at the master model, and then these bodies would update because they're have external references back to that main part. Okay, so you don't have to do sheet metal. Obviously, sheet metal is usually used for sheet metal, but you can bend up plastic, cardboard, paper, whatever you want to do. It's something that you have a flat of, and then you fold it and do some origami, and you end up with a different shape. So you can do that same sort of thing here. First, I have to make this into a piece of sheet metal because right now it's just a solid body. There's different ways of doing that. Probably the easiest way is just to hit this convert to sheet metal feature. And if you pick a face, it wants to turn that entire face into a piece of sheet metal. All I need to do on my side is tell it what gauge it is. You have the choice as to whether you want to keep the body, the underlying body that I brought in or not. I'm going to choose not to. It'll erase that body and I'll just be left with the sheet metal. I'll go over what the rest of these settings do here in a second, but for now, I'm just going to turn this thing into a sheet metal part. And there we go. Now I've got a cut list with a sheet metal body. It's got the same flat pattern feature now that we're used to, and it's got a sheet metal feature where I can control the gauge and the K factor, the auto relief and all that. To get this thing to fold up, what I need to do is I need to start sketching on it lines. So if I draw this line here, then I'll put a point and make sure that this point is concentric with these holes that they've punched into the cardboard. That's a horizontal line. It doesn't matter whether it goes all the way across or partially across or fully across. SolidWorks is going to send that line out across the entire part when you go to bend it. You want to be aware of that it will bend everything along this line. And I'm going to use a sketched bend. What you do is you pick a face that you want to have stand still, and then you can type in what angle you want this thing bent to, or whether it's bending the correct direction or not. It's going to use the default radius and the default bend allowance. You can override those, with these check boxes if you'd like to, but I'm just going to leave them at the settings. Also, where I drew that line, by default, it's going to bend it right where that line happened. You can have it bend to one side or the other, or one bend radius out using these bend position tools. But with this type of thing, as you're modeling this, you just keep going through, drawing more lines and putting in more bends until the thing's all bent up. I'll just put in one more quick one here just to show you that even if I just have a tiny bit of a line, should still work. I say should because I didn't actually practice this one, but yeah, it does. It sends it all the way across. There we go. So you can start bending that. Watching me draw those over and over again is going to be like watching paint dry. So I'll just go right into this one and we can roll through what I've done here. I showed you the first two that I wanted to do, and then I just continued bending them. You see that SolidWorks does not give you a warning or anything if the bodies run into each other, which is kind of unfortunate. It will give you a warning when your flat runs into itself, when it tries to flatten and can't do it without having some sort of internal interference. But typically, SolidWorks is not looking for internal interference. So you kind of have to just use your eyeballs here. And one more bend takes care of that problem anyways. And the last piece up, and then the two ears on the side go in. There we go. That's how you fold up the outside of a cardboard box. When you look at a flat pattern, when I go into flatten it, flattens the whole thing. Flat pattern also does always show you this extents. That's the largest piece of metal you'll need for this design here, or largest piece of cardboard, I should say, in this one. It's funny, I actually had one of the guys here at X, when he was making sheet metal designs, he would have me send out a DXF of the flat, and then he would cut it actually in cardboard, get some masking tape, and make a highly disposable prototype, just to make sure that all of his faces bent like he thought they were going to. You can also, if you want to make configurations and show what the bend process is, when the part is flattened, if you suppress a particular flat, you can just bend one at a time. If I did this as configuration, I could say, okay, this is bend 1, this is bend 2, this is bend 3, that sort of thing, and capture those suppression states in those configurations. So going from a flat to a piece of sheet metal, first you have to convert it into sheet metal so that it has all those items that SolidWorks needs, as far as what the gauge is, what your K factor is, and all of that. When you do the convert sheet metal, it gets that sheet metal feature and that flat pattern feature, which will key SolidWorks into making the bends for you. So I talked about the guy that used to have me send out DXFs of my flat patterns. You can do that very easily in SolidWorks these days, if you didn't know that. If I just do a file save as, and I set the file type to a DXF or a DWG, both of them do the same thing. When I hit save, it takes me over into this property manager. So typically if I did a save and I saved like as an STL or a step file, it would just give me an external file and I'd be done. But when you save a DXF from a solid, not from a drawing, it stops and it asks you some questions. If it is a sheet metal part, it'll have this, and it's basically going to shoot out the flat pattern for me. If it's not, if it's just a plate, you can pick a particular face that you want your DXF to be, but it's going to give us a one-to-one 2D representation of either the face that I select or the sheet metal flat. Let me show you what I'm talking about. When I hit the green check mark, it's going to show me a preview of what this DXF file is going to look like to the person on the other end. That's it. So they can send this directly to a laser cutter or a water jet or however I'm going to have this thing cut out. If there's some particular geometry that I'm not happy with, I can actually edit this before I hit save. I want to take out those eye holes for some reason. I can do that. Hit save, and then I'm going to get a DXF that's one-to-one. Somebody can just send to their cutter and start making us some parts. Okay. For those examples, let me show you some different ways of making boxes. There's lots of different ways to do it. Usually the correct way is whatever is easiest for you in the application you're using. But let me show you some different styles, and then I'll show you the two that I commonly use. So one way that you can create a shape is to create the flat and then bend it, sort of like that cardboard that I was just doing. So I need to put in my dimensions. There we go. Fully defined part here. I'm going to go to sheet metal. When I was doing base flange tab before, I was using an open contour. This is a closed contour. So if you use a circle or a square or something like that, and you hit the base flange, rather than it adding material thickness like a thin-walled feature, what it's going to do with the closed feature is it's just going to fill it in with whatever gauge of metal you want. You can reverse the direction if you'd like. Crazy. Come here. Here we go. Reverse direction. You'll see that it toggles which direction the metal is going to be, but that's it. All you can say is, okay, this is this thick, and then you set up the K factor and the auto relief that you want in the part. And now I've got a sheet metal part. Unfortunately, I can't do the sketch bends in one sketch. It'd be nice if I could just draw another line over here and have both of these sketch bends drawn at the same time. But you do have to do them one at a time. Now, before I was hitting do it at the line, but that's going to be problematic here because where that line is, the inside bend radius is making it so that it's bending this edge of the part, which is typically not what you're after. If I go to the inside, it only gets worse. If I go to the outside, better. Still starting to kick up this area. If I go this next one, that's one bend radius out. And then I don't accidentally tear that corner up. But that's a common mistake people will make. So when you are on this sketch bend, what you do is you hit the face that you want to have keep still. So that's your fixed face, and then it will bend. It will keep whatever the last option was that you had for your position or for your angle up there for your next one as well. And as I showed you before, I typically will mirror the entire body of the sheet metal. So, you know, if I had done a cross, I could have a box with 4 sides, but you get the idea. Now this will unfold. Gives us a nice flat, but it's kind of hard to control. I don't really care for having to calculate where the bends are and the stretch and all that, because I start losing an idea of how tall this thing's going to be or what the extents are on the outside of this. It's not 40 anymore. Now it's 40 plus my bend radius. All right. Let me show you a couple more ways to create a box. Sometimes when you are creating a box, it's a good idea just to draw the size of box that you're after. So I'm after a 40 by 40 cube here. So I'm going to create a couple of boxes here and extrude them out 40. That's not 40. Try that again. Not length to thickness. 40. There we go. Okay, so I've got the extents of my part. There's 2 ways to create these 2 solid boxes into a hollow box. One is using our old friend shell. Pick this face, I put in the thickness that I'm after. I want to shell this to the outside, and now I know this box fits in a 40 by 40 cube. Or a 40 by 40 cube will fit into this box. However, this box is not going to unfold because it doesn't have a tear down the side of it. Go back into the sheet metal tool. Here's a tool that's not really for sheet metal. It's for preparing something to become sheet metal. It's called rip. If you've got an edge on a solid that you would like to tear apart and have it flatten, you can use this rip command. I can do, if I do where it has one arrow, it's going to give me an overlap or an underlap. So you see that the direction of the arrow is the face that's going to get cut if you're doing that. If I have it where there's 2 arrows, it's not going to do an overlap. It's going to do a butt corner where those 2 edges butt up against each other. And you can do all the corners in one shot. So I can pick this. Okay, I need to tear all 4 of these corners. This is where the gap, this is the gap that runs along the inside of that. So that's where that 0.1 millimeter is, how close those are getting to one another. So now I've got a box that has tears down the corner of it so it can unfold, but it's still not a sheet metal part. Right next to the rip command, there's this one, insert bends. This is how SolidWorks used to have to do sheet metal a long time ago, is you'd build the thing in what they call it sharp condition, and then you would insert the bends. Because you see that none of this has any bend radius information or anything. It's just very prismatic. If I choose to insert bends, the first thing I need to do is pick what the fixed face is. And then I have the typical sheet metal types of settings that I do here as far as what the auto relief or the bend allowance is going to be inside of this part. It will always show you this. It's not an error. It's just telling you, hey, I had to make auto reliefs. That's fine. So this is what happens when you do a insert bends. SolidWorks puts in these 2 features. This feature is where it stores all of the bend information. So if I wanted to change the bend radius on any of these, I can edit the feature on a particular one and override the bend radius, kind of like I was doing earlier with that, with my base flange tool that had all the bends after it. Also, if I suppress the process bends, that's what creates the flat. But it's a much better idea to go into this flat pattern folder You see that each part has its own flat, at least each sheet metal part. This one's still just a cube. So you can do it two ways. You can either select on this tool, flatten that flat pattern, or you can just pick on the body, hit the flatten tool, and whichever body you selected, it's going to flatten that one. Okay, I told you about the bounding box that it draws around your sheet metal part. And what it's doing right now is it's trying to find the smallest piece of metal that I can get away with for making this box, which is great if I'm being particularly frugal. But sometimes the direction of what they call the grain, sort of like wood, metal actually has a grain in the way that it's produced when it's rolled, gives it a grain. And when you bend, not with that grain, if you bend at an angle or something like that, sometimes you can have not so great results on your corners. So if I want to change how this flat pattern is laid out, I'm going to add the edit feature. So I click on the flat pattern, edit feature. Remember, this was the place where I could set all those settings for how the corners look. But I can also tell it the grain direction goes this way. I'm using this linear edge. Use one that you guys can see easily. I can just say the grain goes in that direction. Then when it flattens out, you'll see that it's no longer trying to give me the smallest piece. It's trying to fit that square in there perpendicular or parallel to that grain direction. Fold that back up. I have one more part here, and I'm going to use the convert to sheet metal. So earlier I used convert to sheet metal just on a flat face, on that cardboard thing, and I filled the entire thing up because it was just a closed contour. But here I'm going to pick this face and say, okay, that's where the metal is. I can pick whether it's to the inside or outside of the box that I drew. Also, whether or not I want to keep that box for later. But here's the rest of the settings that I didn't really tell you much about, is I can pick these edges and it'll send a flange, an edge flange up that face. I can even close off the top of this thing if I wanted to with a secondary set of edges. But that is yet another way of creating that same box shape. I would favor this one just because if we start taking a look at what the flats look like, this one's okay, but again, my design intent was to have 40 millimeters on either side, and I couldn't do that unless I drew my original base smaller. With these, I'm getting much better results on it being able to fit a 40 by 40 cube inside of it. But if I take a look at this one that was done with it put in really giant bend reliefs for me, or auto reliefs for me. If I had turned off my auto relief, it would have not put those in there. But that's one thing that you want to be cognizant of is when you do that insert bends, a lot of times it can give you some really harsh bend reliefs for some reason when it calculates the tear. But this one, when I flatten it, really got nice clean edges on it. And more importantly, because it's forming to that 40 by 40 box, I know that it's 40 by 40 right away. So that's sort of the box that I'm after. I don't use the convert sheet metal a lot, but I can see that it is a really nice tool if you have the extents of the box that you want. You kind of just coat that box with metal using that convert tool. But here's how I typically will build a box. There's a couple of ways. It really depends on how fancy the box needs to be near the top. If it's going to have a lip or something along it, I like to use something that's called a miter flange, which I don't use much in its traditional sense. You'll see when I create my next model that I have some miter edges, and I typically just use an edge flange. Will miter itself these days. So before the edge flange really came to as powerful as it is today, you had to use the miter flange to get the thing to trim to itself. But now, typically the only thing I'll use the miter flange for is an operation like this. First, I'm going to create just a flat piece of metal. Got the sheet metal gauge, got my flat pattern, all that sort of stuff. There's nothing to flatten out right now. There is a trick when you're sketching. If you pick a face and you choose to sketch, it starts using that face as a sketch plane. But if you select an edge and you hit your sketch tool, what it does is it places a plane on the end of that edge, perpendicular to that edge at whatever the closest endpoint you selected was. And so I can draw this shape right on the end of this piece of metal. So if I just wanted to have a rim around the box, I could do this one. This one's actually going to have sort of a lip that comes up that a top will fit onto perfectly. All I need to do is put in the correct dimensions. So this distance here, and then the overall height. Is right there. So this gives me a cross section of what I want one of the walls of this box to look like. I'll go into my sheet metal tool. Now I'm going to choose to do a miter flange, and you'll see it puts in my bend allowance for me, or my bend radius on the corners if it can. It looks like my sizing here is not big enough to fit in. Try this again. There we go. So I could tell by my preview that the bend radius I had in there was not going to work for me. Now, when I'm doing a miter flange, if I continue to pick edges, it'll continue to put that wall up along that edge. And what the miter is referring to is where the corner is on these things, they're going to miter to one another. And whatever gap distance I put in here is the distance that miter is going to have, room to breathe in. That's as close as those edges are going to get to each other. So if I do all 4 edges, I get this shape. It's got some crazy stuff going on here, but I didn't have to calculate any of that. And I'm going to get a really pretty flat pattern, when it comes to what the corner looks like and what this top edge looks like. Create that box. Now I also want to have a lid for this box. I'm going to do it as a multi-body part. I covered in weldments doing multi-body parts. Just like that cardboard part that I had individual bodies. You can shoot the individual bodies out if you need them to be tracked as their own parts. If you want to have individual part numbers for the parts and that sort of thing, a lot of times we'll do that. But it's a good idea to build it as a multi-body part when you're doing things like boxes with lids, so your lid is always going to fit. There's never going to be a time that you have a lid that doesn't fit your box because the lid is actually defined by the box. All right, with that said, where I'm going to put this lid is I'm just going to start a sketch on the top of the box. And I'm going to convert the bottom of the box, that same sketch that I used to create the box, I'll use to create the lid, and turn it into a piece of sheet metal. By default, SolidWorks has the merge results turned off when you're doing multi-bodies because you don't want to have your sheet metal just one of them working like that. You want to be able to see both of them. Let's do an edge flange for this lid. You can see that as I go around each corner, you can have it, it'll do the entire edge of that corner to whatever depth you're after. You can also choose on this one, I'm going to go towards the inside. And it looks like this is way too deep. I can have it go to a particular vertex, which is another thing that's great about, building this stuff in context is I know that these things are going to fit because this is going down to the vertex where that bend is. And so now I've got a nice flat for my lid. That's typically how I'll do enclosures, is using either one of those tools. If it's just got a regular top, that's fine. But if it's got something a little more fancy, I'll usually use that miter tool. Get myself a pretty complex box really fast. Cool. Any questions? Okay. Bring up one more part here. This one's going to be pretty complex. I'm building a box. Typically, if you've got an enclosure, you use the tools that I showed you in those last examples. But you can also use this base flange tool to create your model. Just like an extrusion or something like that, if you don't see the yellow highlight, it means you've got some problems. When I first came into this, it was using that 12 gauge metal, which is pretty thick, and it just wouldn't have it. It could not fill in these radiuses with that. If I reverse direction, you'll see, I can see that this is going to work for me. I do want it towards the inside, and for this size, I want it to be that long. Okay, so there's my sheet metal part. No great shakes there. It's just got a sort of complex corner going on there. I'm going to create an edge flange off of this thing. I showed you before that it's going to do the entire edge if I just leave it on its default settings. I want this thing to go towards the outside. But I want to get a much more complex shape than that. So I'll go into that edit flange profile that I showed you very early on. And you'll see that this is underdefined, the height. It just started off with whatever extrusion depth you typed into that edge flange, but we can set that with a dimension as far as how high we want it. Now, if I put a dimension on how wide I want it, I'm going to get an error because everything's fully defined. I have fully defined sketch here. Everything's black, but these edge flanges are very strange. They start off fully defined because they're locking to the ends of the original line. But if I just click and drag them, now all of a sudden, underdefined, that one is blue, and I can put in a width that I'm after instead. I also want to have it fit into this shape here. So you can get pretty complex with the dimensions that you have on the edge profile. And what I mean by complex is I'm actually going to select some edges here and do an offset. Hey, all right. Do that. I did the offset, but I don't actually need this line. So it is a sketching procedure. You have these same sort of sketch rules that you have with a regular sketch. I want to make sure that this thing is a closed contour. So right now it's telling me it has both open and closed contours. Once I trim this thing up though, here we go. I get that sketch is valid and I get the preview shown here, how that flange is going to look. There we go. Hit the flatten. I always hit the flatten. I'm always paranoid that I'm going to have something run into itself. So it's always good, just a reality check to do the flat pattern. Like I said, typically the vendors that I work with don't care about my flat patterns. I care about my flat pattern just because I want to make sure that this part actually can flatten out. I can do a break corner. I'm only designing half of this part, so I want to be careful with the break corner. I don't want to break all this stuff. Oh, that's a lot more than I wanted. You can pick just an individual corner to do the break with as well, sort of like a fillet. And then I want to have the straight edges on either side of that round come off as a flange. Now, both of them are going to be the same size when you do them on their own. If I say, okay, both of these are 13 millimeters high, that's how high they are. But you can do independent things with these. One thing, they don't have to go the same direction. These purple arrows determine direction at each edge flange. Also, if I select a particular edge, see it highlights in the screen, and I hit the edit flange profile, I can have this one be a different size. Now I got one that's 15 and one that's 13. Inside of the same feature. There we go. I actually changed both of them, so but I can manipulate them one by one. And when I double click on the dimensions for this, here come the dimensions. I can control each flange with parametric dimensions from the feature tree. All the edge flanges that I've done at this point have been coming off at a 90 degree, which is by default, but you can change this to a smaller number if you want. So I'm going to do a 45, 18 millimeters. Oops. It's giving me an error. One nice thing is it's able to do it, but it's giving me, it's not really sure what I want to do here. That it's not able to put it in the relief there. So I either need to put in my own relief or I need to go in and edit the feature. I think the problem is just that I had that going up, and the bend was supposed to be up above where that edge was, and that was what was causing that problem with that corner. But if I do it one bend radius out, I'm golden. So it does give you some warnings as you're modeling and you run into problems. It'll warn you if your flat pattern is not going to flatten. It'll warn you if you have something like an edge flange that was not able to put in auto relief when it was needed, like in that example. Here we go. I'm doing another tool I've already covered, which is the sketch bend. You pick the face that you want to have still. angle you want it bent and the direction of that angle. And you can also play with, the bend position. I want that right in the middle of this one. There we go. All right, let's flatten it again. Whoop. Hey, hitting that wrong button. This button, flatten. There, it flattened. So this is why I'm always doing that, is to make sure that if these two touch one another, that's when this will show up with an error on it. And you got two choices. It'll either flatten and show you an error, or it just won't flatten at all with an error. Either way, you want to take care of it. It's probably some internal interference that's happening where the bodies are actually, or the main flanges are running into each other when they flatten out. Okay, I need one more tool here. I want to put a punch in here so that I can put in a screw and have some head clearance. So how do I do that? Well, first off, let's take a look at the geometry. This is the geometry of the punch that I want. So I modeled this myself. It was pretty easy. If we take a look at my feature tree design, I just modeled how big I want this thing to be. One thing is you have to make sure that your radiuses here are equal or greater to the gauge that you're punching the metal into. Because when you punch this into the metal, it's going to deform one side and it's going to deform on the other side as well, that same shape, offset one material thickness out. So if you have tiny radiuses or something like that, that's not going to happen. The other side isn't going to have that geometry, and it will give you an error that says that your forming tool is too small for this gauge. The next thing was I did a split line where I just drew a sketch and broke up those concentric circles. That will make a sense in a second here. And then I just put a base on the bottom of this thing. Doesn't matter how thick that base is, what shape it is. I just want to have this flat surface, which is where the tool runs into the sheet metal. So once you've got the shape that you want to punch into the metal all modeled up, it's time to create a forming tool. Here's a forming tool feature right on my SheetMetal toolbar. The first selection it wants is that stopping face. That's where it's going to hit the metal. You do not have to remove faces. If I just wanted to punch a shape into the metal, that would be it. I just say okay and I'm done. But with this, I actually want to punch a shape and remove material. So you have to highlight any of the faces. You can pick more than one face. Any one of those regions, it's going to remove the material on the other side of that when it goes into the sheet metal. And say okay. Now it color codes the whole thing. The yellow part is my tool. The blue is where it stops, and any red faces are going to be removed from the sheet metal. I'll just save that, but I'm not done yet. I need to put this in a special place where SolidWorks will realize that it is a forming tool and not just some model. And that's in my design library. In your default design library, there is a forming tool folder, and you'll see that the rest of these folders all look like folders, as you might expect. But if you right-click any folder and say this is a forming tool folder, now anything that goes in that folder will be a forming tool. It's a toggle on or off. But this one right here is the default forming tools that come with SolidWorks. Let's say that this is an emboss. Got a few other ones, putting in dimples and things like that, slamming in a dome, circular emboss. I want this hole punch here. All I need to do is just drag the top icon from my feature manager tree and drop it into this area that shows me all my forming tool folders. And I automatically go into the add library feature, which will put this puncher into that list of forming tools. So that's how you make a forming tool. It's pretty easy. Once you've got it made, you just drag and drop it onto the face that you want it punched into, and it shows you a little preview. You have the choice of which direction it's going to punch it into. Also, you can change the angle. It doesn't really matter here because it's circular. This has changed over the years. It's a lot easier to work with now. It's a lot like the hole wizard. When I go into the position, by default, it puts me in the point tool. If I start putting more points, every place I put a point, I get another punch. I just want the one punch, so I got out of the hole tool. And I'm just going to use, it's got this line. That's what's going to go to the center of my forming tool. All I'm going to do is make sure that this stuff lines up. Where I've got a horizontal line coming out of the center of this flange and put those holes together. Sometimes the preview does not always update. Usually just switching to the position will refresh it for you. But there we go. It's put in that punch for me. So now I have the head clearance. I can put in a screw there pretty easily. I can also start a sketch on this face. Convert the edge of that tool. You see that it remove that material from the sheet metal in front of it, but it doesn't do like a through all. If you need to have a hole on the other side, you're going to need to do that just like this. All right, so that is creating a forming tool. Punching it into my part. This is supposed to be a box. Doesn't look a whole lot like a box yet, but if I go to my mirror this body here, it's always a good idea after you mirror to just give it a reality check again and make sure that it's still okay with flattening. In this case, it did not. I was worried about this. Let me try something here again. I do try it about this face instead. Running me into problems. Okay, I must have some geometry wrong here. Let me go back to where I was here because this is a similar part, but I drew it when I wasn't just talking all the time because I'm worried that I got one of the dimensions wrong here in this area. So what I'm going to do is I'm going to go into my regular features and mirror this. So I'll pick this face and the body to mirror. And then I do my reality check by flattening this out. Hooray, it flattens. Let's go the other direction. So I'll do the same tool. Do the entire body. Again, if you try and do features, it's probably going to get it confused and not be able to do it because there's so much going on with sheet metal as to which face and which direction is going where. When you mirror it, a lot of times those features don't enjoy that. It does leave the punches here when you flatten it out. If you want to have a flat that does not have any punches in it, you're going to need to suppress those in your flat pattern, but SolidWorks does not do that by default. All right, so that's the base of this box. I'm going to have a couple other pieces. I want to have a top for it, obviously, and I'm also going to put a shelf in here, and I'll show you some of the new tools as far as like being able to do slots and tabs automatically. So for this top, the reason I'm doing it as a multi-body part is I want to be able to make sure this top always fits onto this box. I'm going to offset this guy here and then just bring the corners so that they're hitting horizontal and vertical. horizontal and a vertical line. Again, it's a good idea when you're doing the model like this to use the geometry around it as far as, what you want, how far you want things to go down, so you can use geometry on the part itself to kind of give you a reality check. Also, at this time, the way that I'm building this thing, if the base changes, my lid is always going to fit on it because it's just referencing the base itself. Okay, so on this thing, I'm going to extrude that. So I started from the back and now I'm going all the way up to the top face. So it's going to change if I make this thing wider. It's also going to change if I make this thing longer by the way that I'm designing it here. It automatically does not try to merge results when you're doing sheet metal. So now I've got two different sheet metal pieces here. I'm going to do that third, like I warned you about. Flip over to this side. And I just want to draw this L shape. It's going to be my shelf that's inside of this thing. All right, good enough. I will turn this into sheet metal as well. Notice that it's always using the same gauge. When you're building a multi-body part in sheet metal, it by default, every one of the pieces of sheet metal is going to be the same gauge. If you don't want to have it the same gauge, you can override the default parameters, put in whatever gauge bend allowances you want. So there we go. This is our shelf. Let's go on to some of the features that are a little newer. And they're so new that I had to add them onto my toolbar here, tab and slot. What tab and slot does for you is if you pick an edge, that edge, and then you pick the face, you'll see that it starts putting in, it's going to put a tab onto the shelf part and it's cut a hole in the lid to accommodate that. You can do more than one at a time. You can do a bunch of them. It'll pattern as many as you want. You can set off how far they are from either end. This is the distance. Here on these settings, where did my... Again, there we go. Okay, so I can set up what the endpoints are. It by default is going to be the ends of the piece. But if I have some geometry where I want them to be measured off of, I can set that up here. This sets up how far these are from the sides. And this sets up the actual length of the tab itself. With that, it puts in two features. It's got the tabs in the slot, and it's got the holes in the lid. All right, I'm going to do another one here if you missed it, even though I did that one twice. So you pick the edge that you want the tabs to come out of and the face that the slots are going to cut into. With this one, I just want one of them. And you'll see, just like anything else in SolidWorks, I don't get that happy yellow preview until I give it something that it can fit in there. So once I got far enough of the problem is that when you add all these up, if it's longer than the edge you're doing, it won't do it. So I can get close to it. And there we go, slots and tabs. So if we isolate one of these, this one's got the holes in it. If I isolate this one, It's yes. Oh, I'm sorry. He asked me if the slot was adjustable. And yeah, you can go in there and play around with all the different settings as far as how big of a gap it gives it for around the tab and all that sort of thing. All right, I did want to one more thing here. These obviously are not complete. I want to have the shelf go all the way to the side, and I want the lid to go all the way to the other side. But it's a good idea to do that because the tab slot tool is not so great at mirroring. Also, I just noticed that this is two pieces. I don't want that. Go back into edit feature, and I'm going to say merge solid. It will only merge the solids that touch themselves. It's not going to merge all four of these pieces into one unflattenable piece of metal. It's going to merge them into two flattenable pieces. So I can get the flat on the lid. And I can also get the flat on the shelf that's inside it. I'm going to go ahead and isolate this body so we can work on it by itself a little, but it definitely will flatten for me. Whoops, I still had the old body selected. There we go. That looks more like that. This one's pretty boring right now. It's just got those tabs in there. Someone was worried that it's not strong enough. So there's lots of different tools we can do to make it stronger. One of them is a hem. If I choose hem and I pick an edge, there's different ways that you can do this. So whether you're dimensioning, you want the round part to come up over the original top, or whether you want the original top to be where the top of the round is. That's what these two settings do for me. Also, this one is going to bend it back, theoretically back to the other piece of metal. It has a really small air gap of like 0.01. There always has to be a gap in there for SolidWorks to be able to unfold a piece of sheet metal. If it's got ununiform thickness, it gets confused and won't do it. So it leaves a little gap. If you want a larger gap, you can do this type of maneuver. Also, they've got the teardrop ones where it comes back and touches itself, or just a piece of an angle. A lot of times they do this type of thing in food service where they don't want to have a sharp corner, so they'll 45-degree bend one, 45 round another, and then weld them together so you get a nice big round corner. So different types of hems that you can do. But this one I'm just going to do bringing it back, and now that's going to make that piece a whole heck of a lot stronger. It's got a parametric dimension, just like anything else, so I can change that hem width if I need to. Another strengthening feature, and that's somewhat new, is the gusset, sheet metal gusset. If you have a corner and you pick the sheet metal gusset, all you need to do, pick the two sides where of it, and it puts that gusset in there for you. You can play around with, the size of the gusset and different types of profile dimensions. So it's got a ton of settings here as far as what that gusset looks like. But what it does is it puts the gusset in there for you on both sides, and it still allows you to flatten that out. Again, I did not pick the body first. Let me stop doing that. Pick the body first, flatten it out. The gusset goes away when it's flat. So you only see it in the folded position. Oh, I want to do one more thing here. And that is, I'm going to just do a tiny sketch here because you've seen me use the base flange tool over and over again in this example or in this seminar. Okay, and shape. Start putting dimensions on it. And it's fully defined. Okay. This tool, however, is not just called base flange, it's called base flange tab. So when you're creating just a brand new part, if you have a closed contour, the base flange just gets filled up with the gauge of metal that you're using. If you have an open profile, it does like a thin walled feature where it adds that gauge to either side of your sketch. But what's this tab? What tab does for you is it just fills in your sketch with material, adds it to the rest of the model. It's automatically going to be the same gauge as the rest of the model. So you're just filling in area with it. So that's, if you've ever wondered why it's got two names, base flange and tab, that's a tab. I was also warning you earlier about the fact that some things can be mirrored, some things can be patterned. Luckily, both of these things can be patterned. Just need to make sure I'm going the right direction, the right spacing. And there we go. You may get an error when you do that. I don't, because I have the settings set. I went through this right before I started doing it. If you have the geometry pattern turned on, that's when you'll get an error. What geometry pattern does is it doesn't try to resolve anything. It doesn't pay attention to any of the end conditions or anything like that. It just tries to give you the same XYZ shape. It's having problems with that because this thing actually needs to remove material off the back of this thing and put material on the front. So it can't do a geometry pattern. It has to actually resolve every one of those sheet metal gussets. Okay. But again, I'm always, when I'm in sheet metal, it's just like a habit, like a nervous tick with me. I'm always hitting that flat pattern to make sure that the thing I'm designing actually flattens out. I haven't made any mistakes. Okay, so I only have one more sort of set of things that I want to show to you, which is good because I've only got about 15 minutes left here. One of them is the miter flange. So I don't know if I've still got that box up. No, I don't have the box that I created, but I showed you how to create a really nice box with a miter flange, and that's pretty much the only time I use that miter flange tool anymore. Or if the miter flange has some particularly sticky geometry, I'll use it as well. I just noticed something. Second here. I got lazy with my sketching. These things are supposed to be tangent to each other. There we go. That makes it look better. Okay, it was going to have a hard time figuring out with that geometry, so just had to make sure it was right. I'm going to use an edge flange. When you're doing just a regular miter, that's really all you need to do. I showed you that you can do multiple edges earlier, but when you do multiple edges that run into one another, they automatically miter to themselves with this edge flange tool. All you need to do is set that sets the edge flange. The other thing that you can set is the gap distance here. So that's how close those two miters come to each other. I'm also going to do this to the outside, so I don't have to worry about running into the material. It's nice also when you're dealing with these parts fit together like they are here in one part. I can see whether or not my flange runs into the other part or clears it like it does in this example. Okay, this box desperately needs some ventilation. It's going to get very hot in here if this thing is full of electronics. So there's different ways to make holes in sheet metal. I showed you creating a forming tool before. There are forming tools inside of SolidWorks that you can use that help you let this thing breathe. In the past, you would have to make sure you hit the right side of the material for which way you wanted the thing punched in. It doesn't matter anymore. There's this flip command. Also, I can change what direction or what angle this thing's at. So which way you want it to be and how you want it oriented are here. The other change that they made, besides not always having to hit exactly where you want it to be, is they've made it a lot more like the hole wizard as far as how you put the items in. There we go. I just want to look straight down at it because it's got a position tab, just like the hole wizard. And just like the hole wizard, it puts me into a point tool. Every place I put a point, I get another punch. So I don't really need to make a pattern. I can just do a pattern using these tools or using these points. There we go. Now I know they're evenly spaced and right in the middle of the part. So that's one way of doing ventilation. You can use those forming tools to punch louvers in there if you need them. There's also a vent tool that's pretty handy. I'm going to start a sketch here, and just to save time so you don't have to watch me sketching, I'm going to bring in a block that I already created of this vent shape that I want. So here's my vent. Place it where I need to be, and I go into my sheet metal tool. Here's the vent command. All right, there's a lot of stuff to pick in this vent command. So you have to do a lot of sketching. You have to sketch out your vent first, and then you use this tool. But when you see what it does, you'll realize it is a big time saver when you're doing this kind of geometry. When it talks about a boundary, that's the exterior boundary. So that's the hole that it's going to put into my part. I can also have an areas that are filled in with geometry. Oops. Get the right edge. Let's try this. So I can do ribs. I can pick some geometry here, call those things ribs, set up what I want them as far as thickness. I can also do spars. Oops. There we go. So I can fill in an edge as well. Okay. I think I got one too many spars chosen here. So it puts in this lattice work for me automatically. And maybe I want to have, you can independently set up, have different size bars and ribs. Okay, so that was pretty cool. It created all that geometry, and I could have done that with a cut. But here's another thing that's really cool about it is if I put in a number here, what that does is that finds every sharp edge and rounds it off for me. So I can get a really nice looking vent pretty quickly. I just have to draw the basic skeleton of it, and then SolidWorks do the rest for me. Let me isolate this part, so I'm just looking at that one. Do one more type of vent using a tool I showed you a little earlier in this seminar, and that was the fill command. And when I did the fill command, I filled the entire face of the thing with holes. Here, I just want this area filled in with holes. So you draw a box on what you want this thing to look like as far as its footprint. And locate it. And the feature I'm going to use here is a split line. Because by default, the fill pattern will automatically fill an entire face. That was weird. There we go. Okay, so I've got this face now. That's what I want to do. So I don't want to fill the entire back with holes. I've already got these louvers and vents and stuff. I just want this area to be able to breathe. So I use the split line to break it off from the rest of the group. And now I'll go into a fill pattern. When I created my fill pattern last time, I was using a feature. You don't have to use a feature. You can have it create just simple cuts for you, whether they're squares, circles, diamonds, or in this case, I'm going to do hexagons. So 3mm hexagons are what I'm after. Fill that face with 3mm hexagons. It does just that. I can play around with what angle they're off to each other, whether it's rank and file or staggered checkerboard kind of style. How close they are together, what angle they are separated from each other by, that sort of thing. There we go. One thing you do have to be conscious of, when I do the fill pattern with just a regular feature like I did, it'll repeat that end condition, like if it's through all or linked to thickness or whatever. But if you have SolidWorks create the fill pattern for you, you don't have any choice. It's always through all. So if I had done it on the back face of this, I would have holes in the front of the part as well. So you got to make sure you're facing away from the part, because that's always going to go out for infinity when it creates these cuts for you. You notice there's no real end condition there. All right, but that's a pretty complex box. And if we take a look at these, make the lid transparent. We can see, we used a lot of new tools that you may not have used, like the gusset or the tab. And some tools that have been around for a long time, like the fill pattern or the forming tools that you might not just have known about. So there we go. That's the SolidWorks seminar. Next month, we're going to be doing another tips and tricks to try and follow up on our wildly successful tips and tricks from a couple of years ago. And we'll have another weldment seminar this month. So look for that. And I will see you guys in another month.